Okay, 6-4 logarithmic functions. We are going to graph and find the inverses of them. Okay, log, and we've already discussed this, that exponential and logarithmic functions are inverses of each other, so we're going to end up with a log function if we start with an exponent, going to end up with an exponent if we start with a log function, because we know those are already what they are. Okay, so very basic, we're going to start with exponential. Every single exponential function, unless it moves left and right, up or down, goes through what point? This one you should know.
0.
0 what?
0, 1.
0, 1. Every single one, unless it is moved left and right, because then that alters it, correct? Remember that 0, 1 was my anchor point. So I went through 0, 1. I have a nice smooth arc. And I've got to remember that my x-axis is a horizontal asymptote, correct? And it goes up like this. Yes? That's an exponential function. So we had a y-intercept of 0, 1. We have a horizontal asymptote of y equals 0, correct? Domain is all real numbers. And range is what?
Something 1.
What's the range? What's coming out of it?
Greater than
Greater than what?
1. 2.
0.
0. Thank you much. If the horizontal asymptote is 0, can't it go close to 0? So y is greater than 0. And then, of course, it is increasing, but we can change all that, right? Anything else we need to know about this? Nope. Okay, so exponential. Remember that I just said that exponential and logarithmic are inverses of each other, correct? Yep. And that means the x and the y switch places, doesn't it? So I no longer have a y-intercept. I have a what? X-intercept. Well, switch the places of 0, 1 to what?
1, 0.
1, 0. Because everything that was x is now y, everything's y is now x, right? So an exponential had a horizontal asymptote of y equals 0.
Vertical.
This goes 0. So a vertical asymptote at x equals 0. Domain and range are physically switching places, yes? So what is the domain now? Domain is x. So x such that what? What was the range on the other one?
0. Greater than 0.
Greater than 0, so it's going to be x is
Greater than 0.
greater than 0. And our range is going to be what?
All the numbers.
All real numbers.
And this one's for the log?
Yep. And I'm going to draw it in a second. This is log. And this is exponential. Now, we didn't even draw it, did we? Not yet. We got all of our information off of our exponential function. So if I know what the exponential function is, can I just interchange range of domain and find the logarithmic function? Yes. So it has to go through what? 1, 0, which is right there. And I bet it looks like what? Does that reflect across that y equals the x line that inverses reflect across.
Yep.
So when we did exponential functions, we took that blue graph and we moved it up, down, left, right, correct? And reflected. So when we're going to do logarithmic, we're going to take the purple, move it up, down, left, right, reflect. Make sense? Am I good to switch slides?
Yep.
Somebody said hold on, so I'll wait.
So that second graph is the log one.
Yep, it's purple, so everything in purple is log. Everything in blue is exponential. Are we good? So when I gave you exponential, I gave you it in terms of h and k and all the negatives and positives, right? So guess what I'm going to give you with logarithm? The h and k, all the negative and positives. Now you see two equations up here, but are they different?
No.
One is log base a, right? And the other one is log base what? E. Exactly the same. You don't have to write both of them. You just need to know that it's both. Got it? So what does this plus or minus do at the front? What has it done in every single equation? Reflects over what? X-axis. Okay, now the base is going to tell you kind of the rate, whether it goes fast or slow. It's kind of its rate of change. Make sense?
You want us to write this?
Well, you probably need to because you need to know it. Okay, what does this plus or minus do?
Moves it up and right.
Nope.
Down.
Nope. If the first one was the x-axis, this is the y-axis. Okay, what does h do? Left and right. And it's negative h, so that means it's the opposite, correct? Isn't that what a formula says when it says negative? So that negative is the opposite. If it's negative 6, it's not going left 6, it's going what? Right 6. What does the k do? Up and down. And I'm not filling it out for the natural log because it's everything the same. Yes. So this is the same approach we've taken to quadratic, the same approach we've taken to exponential. Every single equation I've given you, we've done an h and a k, correct? Every single one I give you next year, guys, we're going to have h and a k and a negative a. Everything is going to do the same thing. So all you need to know is what the parent function looks like, and you can move it all around, can't you? For a sketch. So we said it went through 1, 0. So we're going to move the x-intercept, right? That's what's going to move from left, right, up, down, right? That's my anchor point. I'm also going to move my vertical asymptote. What would change? My h and my k change this, correct? How about I put h and k instead of k and k? H and k do that, correct? What changes my vertical asymptote? What part of this would change my vertical asymptote? What do you think? H or K? Okay, so that's going to be affected by H. My range is also going to be affected by what? H. What about my domain? I said that wrong. This is domain, right? Yes. my domain is going to be affected by H. What was my range? Just wrote it on the slide. What was it?
Y such that y all real numbers.
Right. So is all real numbers going to be affected by anything on here? No. So nothing's going to change it. This is also going to be affected by a plus or minus on the A, isn't it? Because that would be a reflection. Or a plus or minus on the X. So these plus or minuses that we have. Now, it's not always going to change, but is it going to affect it if it does? Yes. Anything else we need to worry about? We have x-intercept, we have vertical asymptote. Those are the only things we talked about, right? Increasing, decreasing, it will change if I've reflected, but that's not a big deal. Questions before we move on?
Don't move on.
Okay.
That's one question.
The statement based. Yeah, it's a statement cadence.
Demand action. What time does Decorate get over at 8?
Around.
I'll probably stay the whole time. I don't know.
Okay, we're good?
Yeah.
Okay, so let's actually do it. Does that sound good?
Yeah.
Okay, so this base, again, only affects how wide it is. Got it? So it's not going to shoot off. It's going to stay closer to the x-axis. But other than that, nothing changes there. Okay, so this 4, what's it telling me that's going to happen here?
I'm gonna go up or down.
Okay, so is it going to go up or down? It's going to go up. Okay, so my x-intercept, my anchor point I had was 1, 0, right?
Yep.
And if it's going to go up, does that affect the x or the y?
No.
Hmm?
No. Y.
The y. So it's going up 4, so I add what?
4.
4. So 1, 0 is going to go to what?
1, 4.
1, 4. Is it going left or right?
No.
Is it being reflected?
No.
Nope. So my domain is going to be x such that x is greater than 0 because nothing changed on it, right? My range is going to be what? All real numbers. Now, guys, I am not going to push you to write the range on here in general, but on your test, I'm going to say graph this and state the domain and range, because in exponential, we have to worry about the domain. The range, right? And in logarithmic, we have to worry about the domain. So I'm just going to say state the domain and range. But on your homework, if the range doesn't change, you don't have to state it unless you're trying to get it in that it's always all real numbers. Anything else going to change here? I don't think so. Do you?
Nope.
Okay, so it's going to go 1, 2, 3, 4. So if it is going through this number, my x-intercept has to be somewhere between 0 and 1, correct? Probably pretty close to. Probably shouldn't be very sharp. I guess we didn't talk about one thing. What's the vertical asymptote?
Hi, Brad.
What's the just a second, Brad. What's the vertical asymptote?
0.
X equals 0. Okay. Questions on that? Pretty straightforward. Is it the same way as we've done every other graph we've done?
Yeah.
Yeah. Okay. What's this one going to do?
Move right 3. Move
Is it right 3 or left 3?
left.
Left 3. So it's moving left 3 because it's always the opposite when it's in with the x. So it's left 3. So 1, 0, we're going to subtract 3 for left, right? Is moving to what? Negative 2, 0. So if that changed, my vertical asymptote was x equals 0, but now it is what?
X equals -3.
x equals negative 3 because everything is moving back, correct? Is there any reflection going on here? No. So that means our domain was x is greater than 0. Now it is what? Not less than, greater than. It's not, if it was reflected, it would be less than. So then is the range going to change? Nope. Is there anything else we need to talk about? Okay, so now we need to sketch it. So I want to see that asymptote. And your x-intercept. And then it's lagging. And I noticed it, so I messed up. And there you go. Is it too hard?
No.
Is this all we're doing today?
You're going to find inverses, but it's this. Yeah, that's what you've been doing, except for switching the x and y. Like,
So we don't need to go any further.
am I good to change it?
Yeah.
That one just does what?
Oh, 4.
Up 4. Does it change anything else?
No.
No. Okay, that was it. Do you want to try this one on your own real quick before we move on?
Yes.
Okay, so try this one on your own.
Oh, I don't know how to do
It's no different.
I thought you said we.
This is just base what?
that.
E. It's nothing else that's going to change.
I can do log. This is next.
Mm-hmm.
Would the greater than or less than sign be x is greater than?
Because we didn't do a reflection. The only time that's going to change is if you have a reflection over the x or the y. Actually, only over the y. Because over the x, it's still going to be greater than. It's just if I turn it around over that y. Okay, what does 1, 0 go to?
1, 0,
To what?
1, 0, 1, 4.
1, 4. Why does it go to 1, 4?
Because you're going up 4.
Because we're going up 4. Does my vertical asymptote change?
I do not know. I'm not.
Well, vertical is this way. Did it move left or right?
No.
Nope. So does the vertical asymptote change?
No.
No. So it's still x equals 0. What about the domain? Is it changing?
No.
Nope. So it's x is greater than 0. Did the range change? All real numbers. So every single graph, you're going to look at 1, 0, vertical asymptote, domain, and range.
Is it the not going to be the same as vertical asymptote?
Yes. But the greater than, less than will change whether it's reflected or not.
What is our vertical asymptote?
The vertical asymptote is the line that it approaches but never gets to. So it, we'll draw it. So we get a 1, 4, correct?
Yes.
Okay. And we're going to cross somewhere between 0 and 1, probably close to 1 again. Vertical asymptote here is 0. See how it's close to 0, Jaden? See how it's close to that vertical line?
Yeah.
That's what the vertical asymptote does. Questions, guys? Okay. Now, inverses. What did we do when we found inverses last chapter? What did we do with the x and the y? Switch them. So f of x is the same as y, isn't it?
Yep.
Okay. So f of x equals 10 to the x plus 1. So now it is what? X equals 10 to the what?
Y plus 1.
Y plus 1. And then we solve this for y, don't we? Now, we have been doing these equations all in 6-3, like we've been solving these equations, right? So when it's in exponential form, we have to switch it to what? Logarithmic, because those are inverses of each other, correct? So this is log base what? 10. So we don't have to write a 10, do we? Of what?
Y plus 1.
Nope.
1.
Switch of x. Remember the domain and range switch. Equals
1 plus
y plus 1. Still solving for y. We're not there yet. What do we have to do?
minus 1.
-1. So y is going to equal log of x minus 1. I would highly suggest you put parentheses around your ofs, because we know that minus 1 could be in with the x or out of the x, correct? And here it is out of the x. So now I have g of x equals log base 7 of x plus 5. So this is in log. We need to switch it to what? Exponential, but not quite yet. We need to switch what two things first?
G of x minus
The x and the y, right? So I now have x equals log base 7 of y plus 5. So going from log to exponential. So what's my base? 7 to the x equals
y plus 5.
y plus 5. And then we have to do what?
Minus 5.
So the inverse is y equals 7 to the x minus 5. Now if I want to write it in function notation, it's g to the negative first, right? Inverse of g equals 7x minus 5. And the one over here would be f inverse of x equals log of x minus 1. That's just written in function notation. Have we been doing this stuff other than switching the x and the y? Yes. I got 2 more examples, and that's all I got for you.
Can we do them by
The easy
ourselves?
example?
Yep. You can do them by yourself. Am I ready to switch?
Yeah.
Okay. So you got 2 of those. Can I start?
Yeah.
Oops.
Wait, do we need to write in the other
Where
folder?
did that 3 come from?
You should realize that that's the same thing. I mean, it's not a bad practice to get into.
I got that right, except that little 3.
Well, that's a big thing.
Where is that?
It come right there. And I would suggest putting parentheses around what you're taking the log of.
Can we leave it as y equals, or do you have to put f?
But you have to, that's part of finding the domain. Right? I mean, finding the inverse.
At the end, can we leave it as y equals log of
Oh, you can, but you really need to know that that means inverse. Like, you really need to get used to that notation. Okay, how did they go? Did you guys add that 2 over before you switched forms?
No.
Okay, remember you can't switch forms until it's all alone. So you've got to add the 2 over, then you can switch forms.
But we did the other example like way different. And I'm trying to follow up that example.
Now if I had 3 log base 6 of x minus 4, oh, that's a y. I'd have to do what first? I had to add my 4 and then divide by 3. Then I could make it 6 to the x plus 4 over 3 equals y. Now, that would be a weird exponent, but could it happen?
Yeah.
Yes. That's all I got for you. Your assignment is in Google Classroom.
In my Google Classroom alone.
I can tell you what it is. It is page 6.4, right? So 6.4, 325, 12, 13, 17, and 19 through 24. So not a whole lot of problems. I bet the first problems are graphing and the next part are inverse. What do you bet?
Nothing. $20.